I guess I'm live now. Can anyone confirm if audio, video, etc. looks fine? If yes, then I think we can get started. I was able to solve only 4 problems. So those would be the primary problems that I would be discussing. At last, I did submitted something random for problem E. Looks like system testing has completed. So let me just try submitting solution. So like people in the chat, like do let me know how many problems were you guys able to solve, and let me know if you were if audio, video, etc. everything looks great. Wait 1 second. Why does this submission have a runtime error? So just run it once. So and like do install my Codeforces extension with which you can directly find the link of this video tutorial over here. Like I have added the like the browser link in the extension link in the pin comments. And yeah, this is where we are. Just give me a couple of more minutes and then we will get started. So yeah, like let's get started. Okay, Kiss says only solved one problem. Second one felt doable. Game over. High. Only one solved same year. A and B for the first time in due to congrats. Okay, for this cracked 3 but couldn't submit. From when did you start competitive programming? I don't know. Okay, I think let's get started now. So like the primary agenda is ABCD only. At last we will see if anyone has a better solution, then we can try to discuss it. Otherwise, we will skip it. So when we are at E, I will look at if there are any submissions or any solutions written here. If yes, then we will discuss it. Otherwise, it would be mostly ABCD. So first problem says for any permutation P of even length, like this even length is quite important. You can do the following procedure. Initialize a counter C for each I from 1 to n. Either add I into Pi to C or subtract I into Pi from C or do nothing. Let the final value of the counter be C final. Formally, for each I from 1 to n, consider the set this 0 or this. And choose some x from this subset and set final value as sum of those values. You are given a single integer and find any permutation of length and so that regardless of the operations chosen, the final value will not be 1. So like overall, like the problem says like this. Let's say you have a permutation P. Like essentially we have to find a permutation such P, I believe, yes. So we have to find a permutation P such that the following conditions are hold true. Let's say we choose xi equal to minus I into Pi or 0 or I into Pi. And then if we take sum of all xi, this value is never equal to 1. And then problem asks us to find one such solution over there. Like there can be multiple ways to solve this problem. One of them I see is like this. Like what is the bare minimum that can come to your mind? The bare minimum is would be like you can just choose right 1, 2, 3, 4, 5, 6 up to let's say something whatever the number is. And if this is your permutation pi, like the idea is we will try out some simple ideas on what the permutation p can be. Then what can be I into pi? For the first one, the value would be -1, 0 or 1. And then the value would be -2, 0 or 2. Sorry, actually it would be -4, right? 2 into 2. We have to take I into pi. 4 into 4. Then -9, 0, 9, and keep going. If you keep going over here, then you will realize that you actually don't have any way to form this problem. Like, for example, we have 1, 4, 9, 16, 25. No, actually, there would be many more ways to solve this problem. And like, it would be like take either 4 or -4, take 9 or -9, take 16 or -16, take 25 or -25, and so on. And in that case, if you just choose this value and everything else as 0, then you will get final value as 1. Like, does anyone have any questions on what the problem statement is asking us so far? Like, we have not yet gone into the solution yet. Like, I am trying to play around saying like, how does the problem evolves if we just choose the identity permutation pi equal to I. So the numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever the integer I mean. And what we see over here is like, in that case, these would be the numbers you can get. And you can't really choose much over here. Like, if you choose 1, then also you will get 1. Or if you choose 1 plus 9 plus 16 minus 25, then also you will get 1. And like, so far we have not used the condition that we are being given that the length is even length. And that's actually quite an important observation here. Like, when can the number cannot be, when can we have C final not equal to 1? One way I can think of is like, if we can somehow ensure that this value is always even, then it can never be 1, right? And like, this was the pretty much the main observation. And how can we ensure the value is always even? Ensure value is even. One way is ensure all the numbers are even. Ensure all numbers are even. Then it doesn't really matter you take plus of that value or minus of that value or 0. If all the numbers are even, then whatever you take, you will again get even only. And how can we ensure that all the numbers are even? Let's look at our value array more carefully. We have I here, we have pi here. 1, 2, 3, 4, 5, 6, 7, 8, and so on. Then it doesn't really matter what value we take. I into pi is even only. Here also it would be even. Here also it will be even. Here also it will be even. And what can we do for the remaining parts? One way is like, we can put numbers like this: 2, 4, 6, 8. This will ensure that these numbers in orange are even because of index I, and the other numbers are even because of pi. So essentially what we need is pi should be even if I is odd. And because n is even, the other condition will hold to that pi would be odd if I will be even. And essentially that's the solution for this problem. We just print 2, 1, 4, 3, 6, 5, 8, 7, and so on. So essentially, like the problem, yeah, we can also reverse the number and also print it then also, because n is even, that will work true. And this is what actually the problem wanted you to think for. And any questions, anyone? Yeah, reverse order will also work. So in context, I did printed all the numbers in reverse only. Then we can reverse the number. And this would be the problem A for us. Any questions, anyone? And reverse will work because if n is even, we know that half of the numbers would be even, half of the numbers would be odd. And also half of the index would be even, half of the index would be odd. So any questions, anyone on problem first? Then we will jump on to the next problem. Like do react something so that I know that you understood problem A, and then we can move on to the next problem. And based on the poll, it looks like most of the guys have solved 1 and 2. Yeah, let's move to the next problem. You are given an integer and construct an array A of n distinct positive integer a1 to an such that for all I, overall sum is divisible by ai, or determine that no such array exists. Okay. So like overall the problem says like this. For example, let's do it this way. We have to find an array A of distinct integer. If we say sum is equal to s is equal to sum of ai number, then sum must be divisible by ai for all I. Or in other words, as LCM of all the numbers should divide x. So this is what the problem is asking us. And how do we go about this? The first thing is like the most important, like the easier part is to try to play around the numbers. Let's say if we choose 1, 1, 1, 1, 1, then whatever the sum you get, all of them would be divisible by 1, right? But we cannot choose this because we have been told that we have to choose distinct numbers. So this cannot be chosen. So what is the other choice we have? We can choose 1. We can choose 2. Here the sum would be 3 so far. We can possibly choose 4. Sum would be 11. We can possibly choose 8. Sum would be 15. We can possibly choose 16. Sum would be 31. If you look at it very closely, the way you can see is like if we somehow add s plus 1, then everything will fall in place. Because if we are taking powers of 2, then 32 will be divisible by all the powers of 2. 16 would be divisible by all the powers of 2. 8 would be divisible by all the powers of 2 so far. 4 would be divisible by all the powers of 2 so far. And 2 would be divisible by all the powers of 2 so far. So, like, essentially, if you see, if we keep on choosing the powers of 2, then all we need to do is ensure that whatever the biggest number we have, overall sum is divisible by that. Ensure sum is divisible by, because if all the numbers are 2, then LCM of all the numbers would be the highest power of 2 you have. And if you are choosing it the powers of 2, you can also notice that the sum is very close to being the multiple of the other number. If we can somehow make plus 1 to the sum, then we are actually done with it, right? So, like, actually, if you try to play around, like, this would be one example you would be able to look at for. And can we do something magical over here to get away with like the restriction of 1? Like, for example, if we could have somehow made this number as 2, then everything would have fallen in place. 2, 2, 2, 2, 2, 2, so far. And then the next idea was actually to look at the sample examples actually. For 1, whatever you print, that would be your answer. For 4, you can see that the problem the solution is giving is 1926. So for n equal to 4, one possible value is 1926. Okay, interesting. And here, like, what is your sum? 1, 9, 10, 12. Sum is 18. Right? And what you can actually do is, like, if your sum is 18 and you know that this is valid, then if you want to construct an answer for next, just put 18 here. Then your sum will become 36 and that would still be divisible by 18. And then you again put 36 here and so on. Like, essentially, the idea I am suggesting is start with some very small answer. Let's say AI, A1, A2, A3, A4 you have. And you also know their sum is A1 plus A2 plus A3 plus A4. And let's say you somehow got such numbers to make your answer right. Then what I'm saying is always put sum of all the numbers next. Put sum here, overall sum will become 2s. It's still divisible by that. Now, again, look at the overall sum. The values over here is s. Here you have taken s. So put 2s over here. Overall sum you will get is 4s. And it's again divisible by that number. Next, you put overall sum of, like, sum of all of these numbers is s. If you take sum of all of these numbers, you will get 4s and total sum would be 8s. And so on. So the idea is from the samples, if you have n equal to 4, you know that this is a valid answer because this has been given to you. Now, all you need to do is just look at sum of all of these numbers, put that as the next number. Total sum will become double and the new number you have added would definitely be divisible by that. Again, if you want to add one more number, look at the total sum and put it there. And this way you would be able to solve for everything from 4 up to whatever the big number is. You can notice that the value given to you up to is n is up to 50 only. And here the sum was, for 4 numbers, the sum was around 18. And if you make it up to 46 also, then the max you will multiply would be 2 into 2 to the power 46 or something like that. And that would be within your answer. So you, like, so won't this fail for 50 because 2 to the power 50 exists long? No, 2 to the power 50 does not exist long. Like 2 to the power 60 3 or something exits long long. Like 2 to the power 15 is up to 10 to the power 15 or something like that. And long long can be up to 10 to the power 80. So like this would be one way using which you can solve by taking the samples you have been given to you and solve for the other one. Now all it left is how do you solve for n equal to 2 and 3? Notice what was given to you for n equal to 4, 1926. Here you have 18 some, and it doesn't, you cannot actually make something out of it. If you remove one of the number, then also it will not work. But my idea was like we can just use 1, 2, and 3. Sum is 6, and all of these divide 6. So that was the answer for n equal to 3. And for n equal to 2, you can print -1. We can prove that sum of two numbers can never be equal to their LCM if those two numbers are different. And the reason for n equal to 2 is like we have a1 plus a2, and it should be greater than equal to LCM of a1 comma a2, right? Let's say like the maximum of these two numbers. If a1 equal to a2, then so this works, but we cannot take it. Otherwise, if the numbers are different, then you can see that this number would always be greater than equal to maximum. Or actually, I would even say this would be greater than equal to, like if you have 2 and 8, something like that, then LCM is 8, but sum is 10. So this doesn't work. Otherwise, you can probably notice that this would be at least 2 times of maximum. And you can play around with it, or you can just assume that the answer was -1 and try to submit it, if it was problematic. Like essentially, you can formally try to prove either one of the numbers divides the other one, then the LCM is equal to maximum, but the overall value would be something plus maximum. Or if there are uncommon prime factors, then you can notice that LCM would be more than 2 times of maximum, and while this value would be less than 2 times of maximum. So these equations cannot hold true. So this was actually problem B. Any questions, anyone? Sometimes it's useful to look at the examples because they can give you a lot of hint. Because when I saw 1926, that's when I realized I can probably put 1, 2, 3 because the other two numbers were multiples of 3. So the idea would be as follows. For n equal to 1, you can just print 1. For n equal to 2, we try to prove that you cannot make it. For n equal to 3, 1, 2, 3 is one possible answer. And for the remaining ones, you can just take the 1926 that was given to you. While the size of number is less than s, you look at what is the sum of values. And we just add s to the answer. And at last, print the value. So this was problem B. Any questions, anyone? For the first one, I just printed n to 1. Yeah, that will actually work. So, any questions, anyone on problem B? Like, do react something so I know that everyone understood problem B and we can move to problem C. Okay, let's move on to problem C. Define the alternating sum of the array to be length. This would is the formal value. You are given non-increasing array A of length n such that all I from 1 to n either ai equal to -1 or ai is a positive number. Find the number of sequences such that alternating sum of sequence is 0. Since this number may be large, output at modulo the other value. For a given set, like there are different ways to choose over this, and this is the problem statement actually. So the problem statement says we are given an array A where all the values are increasing. The smallest value is -1 and the largest value can be anything. And let's first choose some of the numbers from this array. Let's say this is A7, A10, A15, and so on. Now we have to take the alternating sum A1 minus A3 plus A7 minus A10 plus A15 such that this value is 0. And we have to count the number of ways to choose elements like this. So we have to count number of such sequences. So this is where we are. And like, how do we go about solving this one? Any ideas, anyone? So, like, let's look at the original number once. Let's say these are the numbers you have chosen, and you know that this is an increasing array. So you know that you will choose B1 minus B2 plus B3 minus B4 plus B5 minus B6 plus B7. Let's say we have chosen odd numbers. And you want this to be equal to 0. Then because you know that this is an increasing array, this value would be positive. This value would be positive. This value would be positive, and you are just left with this number, and this must be negative. I am analyzing the case when I choose even numbers. Total count of the numbers is even. All right, fine. Then what can I say over here? Notice that only negative number possible in the array is -1. Because it says that every value is either -1 or AI is positive. So what you can see is like if I choose this to be -1, then this difference should be 0 or 1. Like one of these difference should be 1, let's say this, and other difference should be 0, and so on. So if the first number is -1, so what I can say over here is if I have this B1, or like even I will make a bold claim ki if I choose -1, then all the remaining numbers should be in pairs. Like B2 should be, if I choose this to be -1, then one of the pairs should be like this. Okay, B2 plus 1 equal to B3, let's say, and then B4 equal to B5, B6 equal to B7. Or probably other way around is you put +1 here. Or you put +1 here and everything else is in pairs. Like that's the only way you can make all the sum equal to 0. Or let's also analyze when we have odd cases. B1 minus B2, B3 minus B4, B5 minus B6. This value would be negative because B5 is greater than or equal to 0. This will also be negative. This will also be negative. That is the odd case. And what we want is like overall sum should be 0. Then the only way that can happen is like this is 0, this is 0, this is 0. And now these two observations are quite important. One thing is if our length is even, odd, and if the first number of the chosen element is -1, then the remaining numbers for every pair, the value should be same. You will have only one pair where the difference would be 1. Or if you choose an even length, then all the values should be 0 over here. Like, but the first two numbers should be same, third and fourth number should be same, fifth and sixth number should be same. Like the idea is, let's say, okay, sir, can't understand. The idea is that let's say these are the numbers we have chosen. Because the original number was increasing, these numbers would also be increasing. Now I write how does the alternating sum of this number looks like. B1 minus B2 plus B3 minus B4 plus B5 minus B6 plus B7. And because B7 is more than B6, sum of these two would be positive. Because B5 is more than equal to B4, this value would also be positive. Because B3 is greater than equal to B2, this value would also be positive. And you are left with B1. You have three positive numbers and one number which can be anything, and sum of everything is 0. So you have a requirement that B1 must be negative, right? That's how some negative and some positive number can make some 0. Some positive and some positive will always give you a positive number. So I am saying, and in the original array, there is only one negative number with us, which is -1. If you look at the original array, then it says all the numbers are either -1 or some positive number. So that's why I am saying now this is a number. Some of these two number would be something positive. This is something positive. This is something positive. And here, if you are -1, then the only way to get everything 0 is you keep one of the pair where the difference is 1 and everything else is 0. Like I am saying, if the difference is more than 1 over here, then you can never get overall sum as 0. let's say if this difference is 2, because this value cannot be minus 2, there is no way you can make everything 0. No, I cannot multiply by minus 1, right? I'm looking at when I have total numbers as even. When I look at the largest two number, their sum is positive, something positive, because B7 is more than B6. I look at the third and fourth largest number. Their sum would be also be positive. B5 minus B4 will be positive or 0, because you know that B5 is more than equal to B4. B3 and B2, so if you look at these two in isolation, their sum cannot be 0. If you take more than minus 1, okay, good one. Let's say you are taken 5 minus 1. Now for the alternating sum, you will multiply it by 1, you will multiply it by minus 1, you will multiply it by 1, you will multiply it by minus 1, you will multiply it by 1. This remains minus 1, this becomes 1. This remains minus 1, this becomes 1. This remains minus 1, and overall sum is still minus 1. If you take even number of minus 1, their alternating sum would be 0. If you take odd number of minus 1, their alternating sum would be minus 1. Okay, like even when I am saying this, all I am saying is this B1 must be minus 1. This B2 and B3 can also be minus 1. Nothing stops us from this. And if I have total odd numbers, then I do the same trick. If I look at the largest two number, their sum will be negative. If I look at third largest, fourth largest number, their sum would also be negative. And if I look at all the pairs, everything is negative. And what we want is sum is 0. That can happen only if all the values are 0. Like I am not yet going into the cases. I am just playing around on what you can do. So in this case, you need to insert you choose B1 equal to B2, you choose B3 equal to B4, you choose B5 equal to B6, and so on. So like this was one important property. Any questions, anyone so far? So this was one property. And let's forget that we have been given this. How do we brute force for this? If you are taking minus 1, but can we take for even, are you asking, can we take even number, negative number in this? In the even case? Then also this doesn't matter much, right? If this is minus 1, this is minus 1, their sum is 0. If this is minus 1, this is 5, then also like the difference is negative only. Like this expression will always be negative or 0. So what we know is, if your first element is minus 1, then you are going to choose some pairs. Most of the pairs would be equal, and only one pair will have a difference of 1. That will give you plus 1. Or if you don't have any such condition, then you will choose some pairs where all the pairs would have equal numbers. So this is one observation we have so far. Any questions, anyone on this? Okay. Then continuing further, let's say if we don't even have this condition, how do we brute force for this? Like, I am not saying you cannot take multiple -1. Nobody is stopping you from choosing these two as -1 as well, or these two also as -1. I'm nowhere stopping you. I'm just saying if you have even number, odd total number, then the first number must be -1. These two can also be -1. They will give zero sum. The equation holds true that difference is not zero. These two can also be -1. These two can also be -1. Nobody is stopping you. Even in even case, you can choose these two to be -1, these two to be -1, and like I am not saying you must choose only 0 -1 or only 1 -1. Now, one way to solve this for this problem is we say dp I s as number of ways to choose numbers from a1 up to ai such that alternating sum is s. Then how do we solve for the next one? Either you go from dp I s to I plus 1 comma s, the case when you don't take anything, or if you add ai plus 1, then you will go to I plus 1 comma s plus ai plus 1, or if you choose minus ai plus 1, then you will go to I plus 1 comma s minus ai plus 1. Like that would be the way to solve this dp problem, right? Essentially you maintain up till number I, what was the alternating sum you have gotten so far. And you can also maintain the count whether length is odd or even. So you know that you have to do plus I or minus I. What I am saying is, like, now let's look at the original sequence. Initially you have either a -1 or nothing. These two are the possible choices for the first block. Then you will choose two numbers, pairs of two numbers, right? What I'm saying is, if you choose 5 here, or like let me put it this way, for the even, let's look at for the even length. If you choose 5 here, then you will have a minus sign here. Which would you multiply by minus sign. Then you can choose actually 6 here. Then what was the negative sum of all the numbers so far? Here the negative number is -6. And then you will keep choosing -10. Then all the remaining numbers would be same. For example, let's say -10, 10, 20, -20. So one thing you can notice is, or another way was like you just choose 5 here, 5 here, you choose -10 here, 11 here, 20 here, -20 here. Then the idea I am saying is, For every number, if you choose 5 here and 5 here as well, then due to this -1, the sum taken for these two numbers would actually be -6. Here also the sum is -6, and you added 5 here. Then again the sum here, your sum here again become -1. Then you choose 10. Here your sum became -11. Then when you choose 11, your sum becomes again 0. Then when you choose 20, your sum becomes -20. When you choose again 20, your sum becomes 0 or something like that. So what I am saying is, for every moment in time, you have AI, so on. Then if I look at the numbers that have been chosen up to so far, the sum here should be -1, 0, or A3, -A3, or -A3 -1. These are the 4 possible sum we should care about. Forget about the case for if I don't take into account -1 so far. Because if your pair is something like that, then you know that you will choose one number A4, which would be just one more than A3. So these are the cases you can have to offset it. Or if your pairs are like this, then you should make 0 sum so far here, or -1. Like, any questions, anyone? Like, you can use combinatorics, but I don't think we really need combinatorics here. Like the same DP idea. I odd or even length and sum so far works. Just that you only keep those states where this S is -1, 0, 1, or S is -AI -1, AI, like essentially near something near AI. You have AI -1 or AI +1, and that's actually the solution here. Like, the most important part is first observing that if the even length is, then the first number should be -1, and everything else would come into pairs. Or the second number, if everything is even, then all the numbers must be equal. With that, now you can see running sum. Whenever you are done taking with a pair, your sum of the numbers so far would either be -1 or a 0. And if you take somewhere in the middle, like, let's go back to the same problem again, pattern again. If I choose even numbers, then if I look somewhere here, my sum would be 0, because both of these pairs were 0. And if I choose somewhere here, my sum so far would be negative of this value, or actually positive of this value, -2. Here the sum would be A3. Here the sum would be A5. Here the sum would be, let's say, A9 if I have chosen. Because I know that I have to choose the other pair, which is -A3. Or if I start with one negative number, whenever I am here, my sum is 0 or -1. Based on if the difference here was 0, 0, 0, or if the difference here was 1, then your sum will become from 1 to -1. So if the sum here so far was 0 or 1, then if I look at A3, sum here would be A3 or A3 -1. If I look at this pair, my sum here would be A7 or A7 -1, and so on. So that's why these four are the only important states for us. And this will actually give you the complete solution. Any questions, anyone on the idea so far? Then we will jump onto the code. Any questions, anyone on the idea first? If now we have to jump into the code. Also, the values can be up to 10 to the power 9. Let's say this is our recursive function that gives us, you start from 0, your sum so far is 0, length so far is 0. This DP gives you the number of ways to solve for. Now we have to make a 3D DP. So I'm just putting it into the map. If you have already computed, then so we can just return whatever the DP we have. If we have reached index equal to 1, the end of the story. If else sum is 0, we return 1, otherwise we return 0. Otherwise, if we don't take the current number, if we don't take the current number, we will go to idx plus 1, else sum remains same, and length remains same. If we take the current number, if we have taken odd number so far, like we just change the parity of the length. Like this would be the first solution, which is a literal brute force we can do if we have to do it in DP form. This will actually give us all the accurate answer. This I expect to get TLE, but can you come up with this brute force at least if you are aware of how to solve DP problems? This is actually n square, n cube, or something like that, but actually gives us the right answers. It will get TLE. Yeah. And the only optimization that we have to do is let's look at current value as AIDX. Yes. If absolute value of L sum minus V is greater than 1 and a difference of L sum and absolute value of L sum is greater than 1, then we directly return 0. Just this one optimization will make it order n and you will get an AC. Wait 1 second. Okay, I will put it this way. If we are past the first index, then let's look at what was the previous number. And if absolute value of this L sum is greater than 1 and an absolute value of L sum minus V is greater than 1, then simply return 0 here. Okay, interesting. Mhm. Wait 1 second. Can you spot something here? I believe we need a small optimization here, something like the previous one. If I if I have already chosen the pair, then my L sum cannot be more than 1. If I add a new number, like I need some optimization here. Like I know that every number so far would be more than either this is -1, 0 or 1, then that's fine. I will choose even pairs and I would be done with it. Or I will add some negative value here and this should be 0. and I would have 1 plus something positive. Either I choose even numbers so far. So let me put it this way. If the sum is 1 and then len is 0, then I'm first saying this is impossible. Does that works? If I have already chosen even number so far or odd number, actually, mhm, like I think in the context, like let's put in one more way to call an alternating sum rather than picking the largest number as negative. No, 1. Like how does that L sum look like? We have some sequence so far. Then if I add a negative number here, positive, negative, positive, negative, positive, negative, positive. No, if I have already chosen pairs, then my sum would be either negative. Huh. If my sum is absolute difference of this value is greater than 1, then I have to choose pairs. No, L sum into V is not something I would be doing. Let me just put it this way. Yeah. So actually, I did have an so I think this was enough over this one. And this was actually one more line compared to like the n square dp, and you would be done with it. Like the overall idea is if you have already chosen all the pairs, and if you initially had a -1 in starting, then your like the alternating sum so far would be -1 or 0. Or if you are going to add a new number, like you have initially odd number and you are doing some plus plus pairs, then after choosing the next number, yours should some come back to again 0. Like if you look at the original pairs, if you see whenever you are done with one pair, your sum should come back to again 0 or 1. So this is essentially the condition checks. If the current sum is 0 or 1, we are good. If you just add the current number and then your sum comes to 0 and 1, then also we are good. If you just remove, like if you remove the current value and your sum comes back to 0 and 1, then also we can possibly find some numbers in future. Or if you add some numbers and your sum comes back to 0 and 1, then also we are good. So essentially the condition is like this. Then we are good, we don't have to do anything. If we have chosen odd number so far, then next number will decrease the value. Then if it brings some back to 0, then also we are good. Then also we are good. Else we return 0. So like in contest, I was doing combinatorics where I was grouping all the numbers y1 and avoiding this scenario. But are there any simple combinatorics solution? Like essentially, I felt that optimizing this DP, explaining the optimization of this DP would be more quicker. Okay, Omar, are you the author? I did not know it. That we intended. Okay, Omar. Oh, interesting. So let's just do editorial is also out. Let's just look at what the author solution is. So this is something we discussed. We can even have some equal number of ways to pick an subsequence. Okay. Okay. Do a case work whether we need to do. So actually this was what I was trying to avoid for. Okay, let's do it this way. Hmm. Wiki. Okay, you can do order and with 2 to the power length minus number of distinct numbers. Okay. Yeah. So actually the Mhm. So actually the way I see is it like, let's say the problem is like this. Okay. 1 second. Side is, let's say if we choose even count of numbers, then we know that we have to choose all the groups that has equal numbers. Or even like the other way which I see from the editorial is this way. Let's count all the numbers we have and how many times each number appears. Let's say -1 appears 10 times, 3 appears 20 times, 5 appears 9 times, 6 appears 12 times, 9 appears, let's say 30 times. Let's say this is the number and number of times it appears. If we have to choose all the even numbers, even length, then you know that we should choose numbers in pairs, right? and every pair should have equal numbers. What are the total possible ways to choose numbers from here? Total number of ways to choose numbers here would be 2 to the power 20. Or if I have to choose even numbers from here, then it would be like this: 20C0, 20C2, 20C4, and so on. And what you will realize is that this sum becomes 2 to the power 19 only. If you have 20 numbers, think of it like this. Let's focus on these 90 numbers. And number of ways to choose sum, and we will decide the fate of this number after we have decided fate of all of these 90 numbers. If we choose odd numbers from here, then also add this to get an even count. Or if we choose even numbers from here, then ignore this one to get final count as odd even numbers. So what I am saying is, if I have total 20 numbers, for a minute let's forget about the first number. Let's decide how many numbers we want to choose from these 19 numbers. Total you will have 2 to the power 19 ways. And if we have chosen odd numbers from here, then take this number as well, so the total number will come out to be even. And if we have chosen even numbers from here, just ignore it. Then also you will have total count to be even. So overall, if we have to choose all the even numbers, then the total number of ways to choose -1 would be 2 to the power 9. Here it would be 2 to the power 19. Here it would be 2 to the power 8. Here it would be 2 to the power 11. And if I have 30 numbers here, then here I will have to choose 2 to the power 29. Can you think of the ways so far? So like this is how you will solve for the even case. When total number of elements you have chosen is even. Now you have a requirement that all the pairs should have same numbers. So that it translates to choose all the numbers even number of times. So this is our even case. Any questions, anyone? Then we will also solve the odd case using combinatorics. For the odd case, we know that the first number should be -1. Then there should be some groups. And we can have one group where the difference is 1. Like most of the numbers will be equal. We can have either this group where the difference is -1, or this group where the difference is -1, and so on. Notice that we don't have a 0 anywhere. So first I would say choose odd number of -1s. The formula remains same. Then you need to choose one group where you would have even numbers. Or the way we look at it is this. So we have chosen odd as a -1, and we should choose one group where the like essentially we can have, for example, if the count is like this: 3 appears 20 times, 4 appears 15 times, 5 appears 7 times, let's say 6 appears 12 times, and so on. Either we can choose these two. Then here we have to choose odd number of elements, which actually, like choosing, if you have 20 numbers, Choosing odd is also 2 to the power 19. Choosing even is also 2 to the power 19. So this becomes, if you choose odd from here, then this would be the number of ways. Odd number of ways over here. Here 2 to the power 6 would be the way for even. And 2 to the power 11 would be the way for even. This is one way to choose over here. Or another way over here is this. Let's choose these to be even count. Again, here the from 20 number of ways to choose even number would be even. Number of ways to choose odd number is again 2 to the power 14. Number of ways to choose odd number from 7 would be again 2 to the power 6. Number of ways to choose odd from here is also even from here is also 2 to the power even. And you can notice this. It doesn't really matter which pair you choose for the odd count. Overall, these values are all the same. Number of ways to, because number of in k numbers, number of ways to choose odd numbers is 2 to the power k minus 1. Number of ways to choose even number is also 2 to the power k minus 1. So once you have decided which pair you are choosing for minus 1, and the product you will get is again same for all of the time. So what you can do is for each number, if x appears f times, multiply by 2 to the power f minus 1, and then count the pairs that have difference minus 1, that have difference 1, and that's all. That would be the easy combinatoric solution over here. First, let's choose all the even numbers. Count, multiply by. This is your number of ways to choose all the odd pair. And then we also count v2 should be v plus 1. If v2 is also there, then we also count diff 1 plus plus. Again, the count would be same, like the number of ways to choose odd elements from each group is equal to number of ways to choose even elements in this way. And this one is actually another way to choose once again. 1 second. This count is still fine. Here, y diff one is 4. Okay, this should be x. And we need to choose, and if we have -1 in the array, then we can choose odd as well. And this would be a combinatoric solution for this. Any questions, anyone? First, we choose -1 odd number of times, and then we choose remaining numbers. By the way, we were considering forcing combinatoric solution by adding update queries, but we figured out that DP solution was just as difficult, so it was fine. Yeah, I agree. Like if there were updates, then I would have probably thought more on it. But since there were no updates, then I simply went ahead with the DP with some only. So yeah, like possibly if you know DP and solved a lot of problems, you may see it faster. But if you're just starting out, maybe finding a combinator mix is actually easier. So this was one. Like the idea with DP was ki, the way I felt was ki, I made few observations on how an alternating sum is possible. Then it was just it was only proving removing some of the states from the DP, and that made it order and solution. While combinatorics figuring it out would have taken more time, and I would say like if you were making it updates or something, it would have been a D or E problem at least. Definitely not C. So this was problem C. Any questions, anyone? So if there are no questions, then we will move on to problem D actually. So okay, for D, I was very close to D, wasn't able to figure out that there can be better options than the first multiple of 2 to the power k greater than AI. So actually for problem D, I was after every optimization, I was submitting one or the other solution here. So we will go on to problem D. Any questions, anyone on problem C? So let's move to problem D then. It says you are given an array A of n integers. Alice and Bob will play a game with this array. Before the game with the Bob starts, Alice can increment any element of the array any number of times. Each increment taking one move. Basically, Alice can, you are given an original array. You can do +1 +1 to all the elements you want. And that is counted as one move. And the game starts. Usually Alice plays first, this time Bob will play first. On Bob's turn, he can choose two indexes and he can swap them in any way he wants. And he can also choose the same elements, so essentially leaving the array unchanged. On Alice's turn, if A1 is even, then she finds the largest j, like the initial prefixes of even numbers, and divides everything by 2. Otherwise, she sets AI equal to AI minus 1. If any element becomes 0, it automatically gets erased from the array. accordingly. The game ends when the array is empty. Alice wants to minimize the number of moves she makes, while Bob wants to maximize the number of moves Alice makes. Note that the number of moves is the sum of initial number of additions and the number of turns Alice has played. How many moves Alice will play with optimal play? Any questions, anyone on the problem statement? The game is like this. You initially have an array A. You can do +1 +1 many times to the original array. Then Bob will swap two numbers and then you get to play one move. Either you can subtract one from the first element if that's odd, or if that's even, then you can choose initial sequence of the numbers and divide them by 2. And your goal is to remove all the numbers from the array. It says removing the array is whenever the element becomes 0, that gets deleted from the array. And as a Bob, my goal is to ensure that you have maximum number of moves. So any questions, anyone on the problem statement before you jump on to how to solve this problem? Any questions, anyone on the problem statement? So like as a Bob, what I can do? Let's first think of what Bob can do, and then that will optimize what Alice is going to do. If all the numbers are even, then doesn't really matter what Bob does. Alice will divide everything by 2 in the next one. Fine. Like Bob doesn't really have a choice over here. If at least one even number exists, at least one odd number exists, and let's say this is the array and odd number is here, then what is Alice going to do? Alice will divide these elements by 2, right? What I am saying is, let's not allow Alice to divide more than one number any number of times. So instead of keeping this array like this, I will keep it like this. Then an odd, and the remaining numbers. So all Alice can do is only divide one number by 2. And he will keep playing over here, like subtract -1 wherever required, divide by 2 wherever required, and so on. At some point of time, this element will become 0. Then as a Bob, I will do is I will just give Alice one more number by moving this to the second index. Here again, I have an even number. And so on. This strategy will ensure that every number is played like this. If number is odd, do a -1. If it's even, do a divide by 2. And you keep doing it. And overall, the maximum numbers that I can force you to play is this sum for all the numbers. because the moment the array has at least one odd number, I will force you to only change one number at a time by keeping odd as the second index always. So, like, this is all Bob can do over here. Like, does this sound natural? Or any questions? Do you see any other way for the Bob to play? Or any questions, anyone so far? Because what I'm saying is, as a Bob, because all I can do is I can swap numbers around. And like if I'm doing -1, then that impacts only one number. So we are good. Only the divide by 2 is the operation that can change more than one number at a time. But rather than allowing you to do half 4 times, if I can force you to do half 4 times, then the number of moves you have played has increased. Okay, if you are asking for the problem, then the problem statement is like this. You initially have an array A. So on. Then Alice will first do some +1 operations here. So on. Let's say new array you have gotten is B. In every turn, Bob can swap two numbers. So this becomes B4, this becomes B2 in however way he wants. That's it. He can swap only one pair at a time. And then it's Alice's turn. Let's say we have C1, C2, C3. What Bob Alice can do is he can choose some prefix of the numbers and divide them by 2. Or he can subtract -1 from there. That's how I want to say. If there are no even numbers, then if he wants to do divide by 2, then he will change 0 numbers. Think even numbers and divide by 2. Or choose the first number and do a -1 there. These are the options Alice has. If there are no numbers in the starting, then if he wants to divide by 2, then he will not change the array at all. That's how I want to state. So this is your problem statement, and Alice's goal is to make everything 0 in minimum number of moves. And Bob's goal is to force you to take as many moves as he can. Now let's look at how Bob is going to play in this game. If all the numbers are even, then there is no way Bob can stop Alice from dividing all the numbers by 2. For Alice, once the numbers are fixed, if he can divide by 2, he should divide by 2. Otherwise, he should subtract -1. If all the numbers are even, Bob can literally cannot do anything, and Alice will keep dividing everything by 2. Or if there is at least one odd number, then what Bob should do is Bob should move that number to the second index. So all the moves Alice make are just limited to the first number only, either half, -1, half, -1, and at some point of time that number will become 0 and move out of the array. Then Bob odd number would be in the starting. Bob should move to the second place, so that first number again becomes an even number, and so on. So this should be the strategy for the Bob, and he cannot do anything better than this. Keep second element odd. And that's all Bob can do over here. Now we have to optimize for Alice. So how can Alice do? Like in the problem statement, it forces you to say if a1 is even, then we have to divide some prefix by 2, or if a1 is odd, then we can do subtract -1 only. I am saying let's lose our conditions a bit. We would say that Alice should choose some starting even numbers, divide them by 2, or he can divide the subtract 1 from the first number. And what I would say is, like, because Alice's goal is to minimize the number, if you are given two options, choose some starting numbers, divide them by even. If there are no numbers even in the starting, then this operation is a waste of time for you because you won't be able to change anything over here. Or subtract -1 from the first number. I'm saying even keeping that loose guarantee will also ensure that Alice does what the problem statement says. Because for any number x, dividing by 2 will make that number x by 2. Half of the value is 1. While subtracting by -1 will just remove one number from it. So, like, Alice moves. Of even numbers and divide by 2. This is one option Alice has. Second option Alice has is -1 on a1. So a1 becomes a1 minus. And in an optimal move, trying to if Alice is tries to do a greedy to decrease the number of moves, this is how he will end up. She will end up playing. So any questions so far? Any questions, anyone? So the overall moves go like this. There would be some phase when Alice will divide everything by 2. And after this phase is over, Alice will focus on each of the individual numbers, do divide by 2 or -1 and keep going. This is how the game will play. Divide by 2 or -1. Like initially, you will keep dividing everything by 2. And after some point of time, you will focus on the individual number the moment the array has odd numbers. Any questions, anyone so far on how this game would be played? Then we will try to optimize over here. Hello, hello. Yeah. So the way Alice will play is like this. If we have to brute force, then the way would be like this. Let's say full array is divided 5 times. Then everything should be a multiple of 2 to the power 5 of 2 to the power 5. Akka 32. So we can once iterate on how many times the full array would be divided by 2. Full move half. We can go from I equal to 0 to I equal to 20. That doesn't change is a lot of things because the number is up to 10 to the power 5. If you do some additions and divide everything 20 times, you will definitely end up with 1. This would be how your bulk operations will look like. Then on an individual element level, you can again keep doing half some number of times. And then you will go to a natural cycle or do a -1, even do a half, and so on. And this would be how you will play this game actually. And essentially, you will whatever the numbers remain over here, you keep do a +1 over here. So this was actually how I foresee this problem to be solved with. And this is what I essentially ended up doing a brute force on to reach all the numbers I need. Huh. First, the answer is infinity. Make all the numbers a multiple of P2, the number of times we want to multiply. I have this function which takes a number x and a power of P2 and finds how many times I should add to get reach that power as the next element. So for each number in the array, I make it to the power of 2 that I want, and I am brute forcing on all the possible powers of 2 I have. And the number of additions I do on the way. Now, this is the array I should be solving for. Then number of times, if the array has at least odd number, then break it. Otherwise, you divide all the numbers by 2 and you increase your count. And you keep a track of how many times you have divided. And then you go for an individual number. That means operations. The number of times you divide it, and you start with x. And the move again here is similar. You again try to brute force on what multiple of power of 2 you made it. So the original number would be this power 2. You keep y. Mhm. No, you first brute force on. How many more multiples of 2 you want? Let me see. What did I do here? PW was the original number of moves we made. Like the number of additions in y to make it the next power of 2. And the way this would solve for is this. Now you decide on individual number basis. This brute force is for bulk operations. Here you are deciding how many bulk operations you will do. If you want to do 5 bulk operations, then your all the numbers should be multiples of 5. And here on each number basis. So this was the number you have after division, and this was the number of times you have already done the divide by 2. Now for individual number basis as well, I will again brute force the power of 2 that I want to do. This would be the number of additions, and this would be the number of moves to make y a power of 2. Here I am making everyone the power of 2 that I have chosen. And then end result for this particular operation would be the number of plus 1 I have done, and the basic greedy on y divided by power 2, because this is the initial number of bulk operations that you have already done. If the number is 0, you don't have to do anything. If the number is odd, you subtract minus 1. Otherwise, you subtract divided by 2. And that's all we have to do. Like the overall idea was Alice first decides how many complete array divided by 2 he wants to do. And then once he has decided that, for each number on an individual basis, he is deciding how much initial half he wants to do by adding some numbers to the original array. And then he just goes greedy. If the number is even, divide by 2. If the number is odd, subtract it by 1, and so on. And this was the actual brute force I had for this problem. And also, I am saying if at any point of time the numbers are up to 10 to the power 5, can you also take help of bit manipulation? Like you can probably try to optimize on this one using bit manipulation or something. Mhm. Okay, I need to do plus one here. Okay. And this was all for the problem D actually. Because like Alice, the intuition for half increase the number of half operation comes from the fact that when you are dividing the number by half, you can possibly decrease that number by a large chunk. Mhm. So we can actually see it with no increments. Like if we don't have any increments, then the solution is same as if the number is odd, subtract minus one, number is even, divide by two, and so on. And if everything is odd, keep dividing by two. Okay, like authors have tried to figure out the formula like number of ones in the bit because that many times you will have to do minus one and the number of bits over there. First remove, first keep dividing by half and then the answer is four same again. Because if you have an odd number, Bob can put it at number two. Okay, fine. Yeah, I see. Like this is what I also did. So yeah, I think I also did the same thing that authors are doing. So any questions, anyone? Like overall, the idea was like Alice will first decide how many division by two he wants to do in the hope of maximizing the number of operations. Then he will also try to make the number more even by doing some plus operations. And then he won't have any choice on the number where he would divide by two if number is even or he will do a minus one if the number is odd. And these are the three different phases he should try to optimize for the overall solution. So we first brute force on the number of times which Alice can divide the whole array by two. And since the number were up to 10 to the power 5, if you divide by number 20 times or so, then you will directly end up with 1 or something like that. So it does not make sense to divide the complete array operation more than 17, 20, something like that. And then once you have fixed the original array, you try to see which next power of 2 you should individually optimize for the current number. Then also you can do few more additional in few more plus operations there, and then you just go greedy, divide by 2 minus 1 and keep doing it. So this was actually problem D. Any questions, anyone? Actually, I don't know how to solve problem E, but yeah, like this is where we are. So I will see if the editorial of E, if I understand it, then I will try to share it. Otherwise, this is the end of the stream. Okay, this is accurate. So like I think this is the hard test case I have. Try randomization manner. And so what do you want the solution that I coded in the contest, I should just add some randomization to it? Okay. Like let's put 30 bits first. It's like this is the my would be number. Honestly, I don't know. I just saw the editorial and I am just doing some random stuff. Like authors did also wrote that. Like honestly, I even don't know what is the probability of my failure. I was just doing something random over here. Like okay, so I don't think it would actually pass. Like what I was trying into the contest was as follows. Like let's just read the problem and we will see if we can solve it. If not, then we will wrap up this one. This is an interactive problem. Additionally, hacks are disabled for this problem. You are given two hidden numbers b and v, such that b is either 0 and 1, and v is some number from 0 to 2 to the power 13. There is also an hidden operation tr, which is either an AND operation or an OR operation. Our goal is to find what is the value of this b, 0 or 1. The interaction proceeds as follows. First, we need a value of x from the interactor. We will send some value x to the interactor, and the interactor will give the value which is either the AND with x or the OR with the x. You then send two numbers m0 and m1, where m0 all the numbers would be 1. Based on the value of g, it will give us mb XOR the given number over here. And after that, we have to output the value what was the original in there. So the way I see is it like we have 30 different bits over here. We have a number of 30 bits. X here. We first just send it once because that's the first operation, right? And then we can should look at the result of X OPV. If this is not, if some bits have changed from 0 to 1 in this X, then we know that our operation OP would be OR and this bit of V is 1. Or if some bit of X has changed from 1 to 0, then we know that our operation would be and this bit of V is 0. That we can definitely find out. But if X ty of V gives us X again, and we don't know how to solve for yet. And the idea would be like we can send two numbers, m0 as 2 to the power that bit and m1 as 0 or something like that. And we can see based on whether this was 1 or 0, we can try to figure out whether a blip, which bit will give us the required XOR over here. Based on it, we can definitely find out. So this was the simpler part. And this is second part is something I did not know how to solve for. So let's see what authors have to say. Okay, I didn't knew we also have v equal to 0. Or how do we solve for v equal to 0? Uh-huh. Okay, let's see. Are irrelevant, okay. Wait 1 second. Can you do operations multiple number of times? We can only do it only once, right? So this part is fine. And what problem Sutter is saying is like we should just okay, it says just send x equal to 1 and we have those bits again. Now if I send x equal to 1, then I can still have response as 1 or 0, right? So honestly, not sure. Like I will just leave it for the authors, and I believe we are done with this stream. So overall, the problem to me feels more like you keep doing something random, and like the thing that I was trying into the contest was as follows: first, send 15 bits 1 and 15 bits 0, in the hope that you will get a 0 or 1 somewhere in the line. Like the idea was, if the operation is and if I have 15 bits, then there is some probability that one of those bit will change to 0. And if the operation is OR and I have 15 non-zero bits, then there is some probability that those will change into 1. I did not calculate the exact probability. So I was trying to optimize with number of zeros, number of ones, so that the probability that I would find the operation is and or would be maximum possible. And then if I was done with and or, if the if I print x and I do not receive x, then I know which set bit it is and I try to solve for this. Now I did not know what to choose for. So my idea was again send divide 15 bits between M0 and M1. Half of the bits are in M0, half of the bits are in M1. So and then try to negate the possibility. Can we have and 0 operation based on what are the set bits we are? Can we have or and 0? Can we have and 1? Can we have or and 1? Like these are the four possible combinations we initially have. And I was trying to remove out few values out from it. And at last I was checking if I'm pretty sure that and 0 and or 0 is not there, then report 1. If and 1 and or 1 is not there, report 0, otherwise report 0 or 1. So honestly, I don't know like what's the success probability over here is, but that is the best I could come up with while trying to solve for this problem. So yeah, I think with this we are done with this stream. Thanks everyone for joining in, and thanks Omar for the problem set. And if you have any other questions, do let me know. Else we plan to wrap up this stream. Any questions, anyone? Like last couple of minutes, and then we will wrap up. So thanks everyone. Like let's wrap up this stream.